Where did everything come from? The planets, the stars, the galaxies, even time itself?
Before you, before Earth, before the sun, before even the first atom, there was a moment that started everything. Science tells us that nearly 14 billion years ago, our universe as we know it began in an instant, an unfathomable burst of energy and heat, expanding from something smaller than an atom into everything we see today. This is the Big Bang, the ultimate cosmic mystery. It created space, time, and the fundamental forces that shape our reality. But what exactly was it? And what came before? For centuries, humans have looked up at the stars, wondering how it all began. Religions, myths, and early philosophers sought answers, but it was only in the last 100 years that science began to reveal the astonishing truth. Yet, despite everything we've learned, the Big Bang remains one of the greatest unsolved puzzles in physics. What caused it? Why did it happen? And most intriguingly, was there something before it? Today, we embark on a journey back in time, to the very first moments of existence, to uncover the truth behind the birth of the universe. For centuries, humanity believed the universe was eternal, unchanging, and infinite. Ancient philosophers, from Aristotle to medieval scholars, assumed the cosmos had always existed. There was no beginning, no creation, just an infinite expanse stretching forever. But in the early 20th century, everything changed. One man made a discovery that would shake the foundations of cosmology: Edwin Hubble. In 1929, while working at Mount Wilson Observatory, Hubble observed something astonishing. Galaxies weren't staying still. Instead, they were moving away from us. Through detailed measurements of light coming from distant galaxies, Hubble noticed a redshift, a shift in the wavelength of light toward the red end of the spectrum. This could only mean one thing: space itself was expanding. If the universe was expanding, that meant it must have been smaller in the past. And if we rewind time far enough, everything must have once been packed into a single point. This was the birth of what we now call the Big Bang theory, the idea that the universe had a beginning. But not everyone was convinced. At first, many scientists resisted this idea. The idea of a changing universe was unsettling. After all, if the universe had a beginning, what came before it? Competing theories emerged, most notably the steady-state theory, championed by Fred Hoyle in the 1940s. Hoyle proposed that as the universe expanded, new matter was continuously created, keeping the density of the universe constant. There was no beginning, just an eternal, self-sustaining cosmos. Ironically, it was Hoyle himself who mockingly coined the term Big Bang in a 1949 radio interview.
My name is Fred Hoyle. I am the inventor of the well-known words Big Bang to refer to the origin of the universe, but I'm afraid I don't really believe in the Big Bang.
But despite his skepticism, the name stuck. The debate raged on until an accidental discovery in 1964 settled it once and for all. Two radio astronomers, Arno Penzias and Robert Wilson, were working with a large antenna at Bell Labs. They kept picking up a faint radio signal, a low-level hum that seemed to come from every direction in space. At first, they thought it was interference, or maybe even pigeon droppings on the antenna. But after cleaning the equipment, the mysterious signal didn't go away. What they had stumbled upon was the oldest light in the universe, the cosmic microwave background, CMB. This faint glow of microwave radiation was the afterglow of the Big Bang, a relic from when the universe was just 380,000 years old. With this discovery, the Big Bang theory became the leading model of the universe's origin. Today, nearly a century after Hubble's discovery, the Big Bang remains one of the most well-supported theories in science. But one question still lingers. If the Big Bang started it all, what came before? If you could rewind time, back through the formation of the Earth, beyond the birth of the stars, and even further, you'd arrive at a moment unlike any other, a time when the entire universe was compressed into a single, unimaginably small point. This is where it all began, but not with an explosion. The Big Bang wasn't a detonation in empty space. It was space itself expanding, everywhere, all at once. In the first fraction of a second, the universe was a churning sea of energy. Temperatures were so extreme that matter couldn't yet take shape. But as space expanded, something extraordinary happened. Matter and antimatter were created in equal amounts, but whenever they met, they annihilated each other in bursts of energy. Somehow, by a process still not fully understood, a tiny fraction of matter survived. That's the matter that makes up everything in the universe today: stars, planets, and even you. At the same time, the fundamental forces of nature were born: gravity, electromagnetism, and the two nuclear forces. These invisible rules would govern how everything in the universe behaves, from the smallest atoms to the largest galaxies. Gravity, yellow glow, the force that pulls objects together, shaping the cosmos. Electromagnetism, blue glow, the force behind light, electricity, and magnetism. Strong nuclear force, red glow, the glue that holds atomic nuclei together. Weak nuclear force, purple glow, responsible for radioactive decay and energy production in stars. These forces shaped the early universe, controlling how energy transformed into matter and how the cosmos would evolve over billions of years. As the universe expanded, it also cooled. Within minutes, the first atomic nuclei formed, mainly hydrogen and helium, the building blocks of future stars. For nearly 380,000 years, the universe was still too hot and dense for light to travel freely. But as temperatures dropped, atoms finally captured electrons, forming neutral atoms. This moment allowed the first light to break free, a glow that still lingers across the universe today, known as the cosmic microwave background. For millions of years, the universe remained dark, filled with invisible hydrogen gas. But then gravity worked its magic, pulling these atoms together, compressing them until the first stars ignited, lighting up the cosmos for the first time. With the birth of the first stars came the creation of heavier elements, the ingredients needed to form planets, oceans, and eventually, life. From an almost invisible point to a universe filled with billions of galaxies, the Big Bang was just the beginning of an unfolding story, one we are still learning to read. But what caused it, and what came before it? The answers may be more mysterious than we ever imagined. The Big Bang, the moment everything began. But here's the problem: what came before it? For decades, scientists have studied the origins of the universe, but the truth is, we don't actually know what caused the Big Bang. What triggered this explosion of space and time? What set everything in motion? The deeper we look, the more mysterious it becomes. One possibility lies in the strange, unpredictable world of quantum mechanics. At the smallest scales, space is never truly empty. Instead, it's filled with quantum fluctuations, tiny bursts of energy that spontaneously appear and disappear. Some physicists propose that one of these fluctuations, under the right conditions, could have triggered the expansion of space-time itself. It might sound bizarre, but in quantum mechanics, things can pop into existence randomly, including perhaps an entire universe. But a quantum fluctuation alone wouldn't be enough. Something else had to happen, something that stretched the universe from microscopic to cosmic scales in a fraction of a second. This is where cosmic inflation comes in. According to this theory, a mysterious, ultra-powerful energy field caused the universe to expand exponentially, far faster than the speed of light, within the first trillionth of a second. This sudden stretching smoothed out the early universe, explaining why the cosmos looks so uniform today. But what triggered inflation? That remains an open question. Some scientists believe our universe didn't arise from nothing, but instead from something else entirely, perhaps another universe. In some versions of string theory, our universe exists as a three-dimensional brain floating in a higher dimensional space. If two of these brains collided, the energy released could have sparked a new universe, ours. This idea raises even more questions. Are there other universes beyond our own? Is the Big Bang just one event in an endless cosmic cycle? Another theory suggests that the Big Bang wasn't the beginning at all, but just the latest in an eternal cycle of expansions and contractions. In this model, the universe goes through infinite cycles, expanding, contracting, and then rebirthing in a new explosion. This would mean the universe had no true beginning, only endless resets. So, what caused the Big Bang? A quantum fluctuation, a collision of cosmic brains, a never-ending cycle of universes? The truth is, we don't know. But every discovery brings us one step closer to understanding the greatest mystery of all. Where did everything come from? Perhaps one day we'll find the answer. But for now, the question remains: what came before the beginning? What was before the Big Bang? Before space? Before time? Was there something, or was there nothing? This is one of the most profound questions in cosmology. The Big Bang marks the beginning of our universe, but was it truly the beginning of everything? Right now, science has no definitive answer. Why? Because when we rewind the universe back to its earliest moments, physics itself starts to break down. The laws we rely on to describe reality, gravity, time, space, all collapse into a singularity, a point of infinite density where our current understanding of the universe stops making sense. But even though we don't have all the answers, scientists have three intriguing possibilities for what may have existed before the Big Bang. One possibility is that time itself began with the Big Bang, meaning there was no before. Imagine trying to go north of the North Pole. It simply doesn't exist. In the same way, some theories suggest that time itself began at the moment of the Big Bang, and asking what came before is meaningless. This idea aligns with Stephen Hawking's no-boundary proposal, which suggests that the universe didn't emerge from something. It simply began, like a self-contained bubble expanding from nothingness. But for many, this answer feels unsatisfying. How can something emerge from nothing? That leads us to the second possibility. What if our universe wasn't the first? Some physicists believe the Big Bang wasn't a singular event, but part of an endless cycle, universes expanding, contracting, and being reborn in a never-ending cosmic rhythm. The Big Bounce hypothesis. Instead of the universe collapsing into a singularity, it reaches a minimum size and rebounds into another expansion, like a cosmic heartbeat. The ekpyrotic theory. Inspired by string theory, this idea suggests that our universe formed from the collision of higher dimensional brains in an unseen multiverse. When these brains collide, they generate new Big Bangs, creating an eternal cycle of universes. If this is true, our universe is just one in a series of cosmic rebirths, and the remnants of past universes could still be hidden in the cosmic microwave background radiation, the faint afterglow of the Big Bang. But if universes can exist before ours, could there be more than just one? The most mind-bending possibility is that our universe is just one of many in an infinite multiverse. Quantum mechanics and inflation theory. According to some theories, during the rapid expansion of the early universe, cosmic inflation, quantum fluctuations may have created pocket universes, each with its own laws of physics. The many worlds. Interpretation. Some interpretations of quantum mechanics suggest that every possible event creates a branching timeline, forming a near-infinite number of parallel universes. If this is true, then before our Big Bang, another universe may have existed, or an infinite number of them. But how can we ever test this? If other universes exist, they would be beyond our observable horizon, meaning we may never detect them. Each of these theories is fascinating, but there's a problem. We can't see beyond the Big Bang. The laws of physics break down at the singularity, meaning our equations stop working. Right now, we don't have the tools to look further back. Future discoveries in quantum gravity, string theory, or new physics might one day unlock the secrets of the pre-Big Bang universe. But for now, we are left with a tantalizing question. Was the Big Bang the true beginning, or just the latest chapter in an infinite cosmic story? The Big Bang is one of the most well-known concepts in science, but also one of the most misunderstood. Let's clear up 3 of the biggest myths. Reality. Space itself was expanding. Many imagine the Big Bang as a massive explosion, like a bomb going off in the middle of space. But that's not what happened. The Big Bang wasn't an explosion inside space. It was space itself expanding. Imagine a balloon with tiny dots on it. As you blow it up, the dots move away from each other, not because they're exploding, but because the surface itself is stretching. Our universe works the same way. Galaxies aren't flying outward from a single point. Instead, space itself is expanding between them. Some believe that as soon as the Big Bang happened, all the stars, planets, and galaxies instantly appeared. But the reality is much more complex. For the first 380,000 years, the universe was a hot, dense soup of energy and particles. It was only as the universe expanded and cooled that these particles gradually combined to form the first atoms. The first stars didn't appear until 100 million years later, and galaxies took hundreds of millions of years to form. What we see today is the result of a long and gradual process, not an instant creation. It's easy to picture the Big Bang as a single explosion, with galaxies flying outward from some central point. But the truth is, the Big Bang happened everywhere at once. There is no center of the universe. If you were to stand on any galaxy, it would look like everything else is moving away from you. And if you traveled to another galaxy, you'd see the same thing. This means that every point in the universe was once packed into that tiny, hot, dense state before the Big Bang happened. There is no single place where it started, because it started everywhere. The Big Bang is one of the most fascinating events in science, but it's often misunderstood. It wasn't an explosion, it didn't create everything instantly, and it had no center. Instead, it was the beginning of space itself, a cosmic expansion that continues to shape the universe today. The Big Bang theory is the best explanation we have for the origin of the universe. It tells us how the universe expanded from a single, hot, dense point into the vast cosmos we see today. But there's a problem. It doesn't explain everything. In fact, some of the biggest mysteries in physics remain unsolved. What we see, the stars, planets, and galaxies, makes up only 5% of the universe. The remaining 95% is something we can't detect directly, something invisible, yet shaping everything around us. First, there's dark matter. Galaxies rotate in ways that defy our understanding of gravity. The outer edges spin faster than they should, as if some invisible mass is holding them together. Scientists believe an unknown substance, dark matter, must be creating this effect. Then there's dark energy, even more mysterious. The universe isn't just expanding, it's accelerating. Instead of slowing down over time due to gravity, galaxies are moving apart faster and faster, as if some hidden force is pushing them outward. But here's the problem. We don't know what dark matter and dark energy actually are. We can see their effects, but we have no idea what they're made of. Could it be an undiscovered particle, a new force of nature, or something even stranger? Another major problem. Gravity doesn't fit with our current understanding of the universe. We have two great theories: Einstein's general relativity, which describes gravity at large scales, galaxies, planets, black holes; quantum mechanics, which governs the subatomic world, particles, atoms, and fundamental forces. But these two theories don't work together. At extreme conditions, like the singularity of a black hole or the first moment of the Big Bang, our equations break down. Gravity, space, and time stop making sense. To fully understand the universe, we need a theory of everything, one that unites relativity and quantum mechanics into a single framework. But right now, we're missing that key piece of the puzzle. But perhaps the most profound mystery of all is why the universe exists at all. The Big Bang explains how the universe expanded, but what caused the Big Bang? Did it come from quantum fluctuations, a previous universe, or did time itself have a beginning? And if everything has a cause, then what caused the first cause? Right now, science doesn't have the answers. But with new telescopes, particle accelerators, and deep space observations, we're getting closer than ever to uncovering the secrets of the cosmos. And perhaps one day, we'll finally answer the biggest question of all: where did everything come from? And why is there something rather than nothing?